First, thanks Khan and Mule for having me.
You're welcome.
Nice.
Thanks for being here.
Yeah, sure. I'm here. My name is Itamar. I work in Hibernate Rhinos on RavenDB mostly. You should go and be a copywriter, honestly. The Lost Station is the best name I've heard ever. Today we will talk about RavenDB. I understood the KAN people do not have any experience with RavenDB, so we'll start from scratch. Just a show of hands, please. Who has any experience with RavenDB? All right. Who use RavenDB in the application or whatever, other than experimenting? Okay. Okay. So, if let's do this on the two polars. If I'm going too fast, stop me. If I'm saying things that you already know, most of you, tell me. So why? What is RavenDB? We'll touch in a second. First, I want to know why. I want to introduce you to why we need this anyway. Quick quiz. Who is this? This is Edgar Code. Ed Code is around the 70s. He invented what we know today as RDBMS. In the 70s, he published a paper, an academic paper, that introduced relational algebra, it's called. This is what became SQL. Someone snapped his idea and it became Oracle. But basically, what we know today as RDBMS, relational database, it's his world. 2012, what happened in between? In between, we had object-oriented programming became the standard, more or less. ORMs became later on top of that to allow us to work with objects-oriented programming with our relational databases, which is tables and rows. And then ORMs introduced programs like select n plus 1, and there in the end I put the terabyte, to say that what Edgar Code wanted to make the cardinal sin in SQL is don't duplicate data. Just put everything, normalize everything, just don't repeat yourself in tables, in data. What actually happened is that we struggled from the 70s to 2012, if the world won't explode or anything. We worked really, really hard for like 30 years or so, more than 30 years, to put all of the data we have into tables and rows, which obviously is not the perfect, it's not a good fit at all for data which is structured. Object-oriented programming, objects, the relational database management systems are not suited for that. So what do we have? The NoSQL movement, as we know it, I don't really like the name, but anyway, everything that is not relational. There are a few subtypes which we can talk about. We won't go into that. We'll talk about RavenDB and get to know RavenDB. RavenDB is schemaless. It means you can take your objects and throw them in. You don't need to set up anything, and it works with your objects as they are. You don't have to do anything besides just throw them in. RavenDB is also scalable. It allows for great productivity, and it is saved by default. We will touch that later on. And because all of those features, we say that RavenDB is a second-generation document database. That means, let's go back a few sentences. RavenDB is actually coming and saying, we are looking at NoSQL solutions, we are seeing what they're doing, and we come and do things a bit differently to address some stuff that we think is important. So schemaless is the base things of any SQL solution, NoSQL solution. Scalability is almost every NoSQL solution will give you that. But what we are doing is we're focusing on productivity mainly. It means like we're giving you a client API for .NET for now, only in .NET, but we're giving you a client API that lets you do things really, really fast, really, really easy. And we are safe by default, which we will discuss this later on. The RavenDB is meant to just run and work. As we said, it just works. It is self-optimizing. It works in eventual consistency. We will touch that later on. It is very extensible. What we're implementing right is we say there is no one size fits all. There is no chance you can take one solution and it will work for all your scenarios. So what we did is we made RavenDB very extensible. We let you decide for yourself what are the points that you want to extend RavenDB in and just go with it. And as I said, the client API is very fluent, it's very simple to use, and is again extensible. And of course, RavenDB is fast. So the other question is when, where, who. The answer is there is no real need today to use any RDBMS. For whatever project, you can convince your bosses or whatever to not use an RDBMS and to use any NoSQL solution, RavenDB in particular. That's going to be really fun to work with, really easy, no mappings, no forcing yourself into tables, no thinking, how should I build my objects differently so they fit into the database. Just go with the objects and work with it. Yeah, so this is the how. And this is generally the agenda for today. We will see how to run a server. We will discuss a bit the APIs that RavenDB offers you. We will touch a bit about how to model your data, how RavenDB is suited to be worked with. And we will touch a bit about the API itself. And I don't think we'll get to that, but generally, RavenDB lets you extend it through the server, through the client. And it's important to know that it exists, this option. So how can I run RavenDB? Generally, RavenDB is a compiled thing, but you can run it in different ways. We have the Raven console app, which is just generally in exe, you just run it, and you can tell it to run in memory, so it doesn't even create any files, any data files on your system. You can, using the console app, you can tell it to run as a service. Windows is a service. You can tell it to run as a service, to install a service, to later uninstall it if needed. You can use an IIS application. You can run it as an IIS application. And on the cloud, you can run it on Azure. There's a bit of discussion now in the main list about that. And RavenNest, which should be sometime soon, a hosted solution we will provide. And of course, the embedded version. The embedded version actually lets you run this server within your application, within your .NET application. And you can enable HTTP, so you can actually run your website and still support the HTTP API, which we're discussing about in a minute. Through your website, you can actually give access to the database if you wish to do so for some reason. The HTTP API. RavenDB is built around a RESTful API. That means every operation is done, it could be done through the HTTP API. What the client API, the .NET client API, which some of you know, the rest we'll see in a second, is a wrapper around that. It actually lets you do all of those commands, the post, the get, everything else through the .NET. But generally, it produces this exact commands. And the .NET API it exists in several versions, and we have the lightweight version, which is probably what you want to use. The 3.5 version, which is a bit, which lacks a few features for compatibility. The .NET 4 version, which is the main version. You have the embedded version, which is it's the same like the lightweight version plus all the server stuff. And that means that you cannot run this on a lot of shell hosting. We compile things on the way and we need some certain permissions. and the Silverlight client, which is basically the lightweight client, but compiled for Silverlight again, and it lacks a few features. And RavenLite, which is a very, very specific version for Silverlight, which allows you to run RavenDB within a Silverlight application. Obviously, it is very, very limited in features, but it exists, and it's the only one today, the only database you can access this way through Silverlight to this day. It is still in beta. That means it isn't in production yet anywhere, but it exists. .NET Client API, as I said, it is a wrapper around the HTTP API. This is what it does behind the scenes. What it does, it adds on that, on the HTTP API, it adds a way for you to use POCOs. Okay, you just create your object, throw it on the API. It gives you strongly typed versions of many functions, creating indexes, which we'll see in a minute. It also creates a unit of work. It implements a unit of work pattern. That means every object you load from the DB using the client API is now change tracked. Whatever change you make is tracked, and if you call save changes to the single second, it will persist the changes that you made, and it implements caching, which perhaps we will see today too. It's a way for the client API to save you many travels to round trips to the server. Yeah. Okay. So the client API is really, really simple to use. There are basically two things to know about it. There's a document store object, which you create once per application. You have this application, whatever application you have, for example, a website, you create it once as a singleton, because it is quite costly to create, and then you leave it there. Whenever you want to do operations against the database, you create a new session from the document store. You take document store.open session, and then you have sessions. Sessions are really easy to create. You just create them, use them, and dispose of them. When you dispose of them, they're doing everything they need to do. If you call some changes, they will persist with changes. They will revert back, and it won't revert back. They just won't commit any changes you didn't call some changes on. Sessions manage transactions and everything else, including sharding for, it's not really here, but as well. This is how the client API looks like. You have document store, which is somewhere statically defined in your application. For example, if you're using this website and you put it in the global ASAX under the MVC application, you open a session, you make sure to dispose of it there, and the session, this is the API you get. There is another method here, toString, which isn't relevant. The advanced stuff we will talk about in a second. We have store. I create a new object, I want to store it in the database. You have delete. I loaded any entity, I want to delete it. I have query and load. Okay, these are my ways to retrieve back entities, change track entities, and include, we will discuss this in a second, and save changes. Whatever entity I loaded and changed through query or load, I need to call save changes before it is any changes I make will be persisted. And either it doesn't matter if I change the object itself through its core properties or call delete on it. I need to call save changes unless if I want to call save changes, it won't be persisted. The advanced client API, what we just saw in the other slide, is actually the more advanced stuff that you can do with the session. Lazy loading and other things that you might need from the session. But generally, it's still on the session level. It is still methods that let you access stuff from the session on the unit of work or whatever else. The third level, which is also accessible from the advent or the document store itself, lets you interact with the thin layer above the HTTP API. That means you can actually talk with the database without all the session and unit of work and transactional stuff in case you need it. For now, that's enough. Okay, I'm using my mouse. Okay, modeling. You know what? Let's see some code before we do that. Are there any questions so far? No. I'll show you from.
I have a question.
Yeah, sure. Sure.
Did I understand correct that all the API communication is done by HTTP?
What, the client API?
Client, yeah.
Yes, the client API issues HTTP commands to the server. Server, let me show you.
There was a session today at RavenDB about WebSockets and the overhead of HTTP.
Okay, I wasn't there. What did he say?
No, they say that there is a quite big overhead of the HTTP to send small commands. Is there any plans for doing a more WebSocket implementation of the RavenDB?
I don't think so, because the HTTP API allows us to implement caching, for example.
Okay.
And it is quite beneficial for us. I don't think we will lose that. Let's start from scratch here. Just a second. Alright, so we have here.
But that HTTP API could be published to more public clients as well, right? You could from a web browser communicate.
Yeah, definitely. I'll show you now.
Yeah.
I'll show you now.
And is there any JavaScript library?
Yes, there is not exactly library. The old studio, which let me show you.
Yeah, sure.
Okay. Okay, so I downloaded the latest. Okay, one more thing. RavenDB is being released about every day. Okay, we have an unstable release about every day. The unstable release is not suggested for production use, but the stable build, which is going out at about once per 2 weeks, 3 weeks, is stable for production use. I will now use the unstable version because it contains the latest studio. This is the build that you're downloading. When you download, you can get it through NuGet, but generally, what it contains is this. This is the client API, the lightweight client. This is the client 3.5, okay, the 3.5 compatible version. You have the silver client here, the embedded client, and other stuff like the compiled samples, the bundles, which we discuss if we have time, the backup application which we provide. This is the web folder is what you extract to any folder that you choose and run it through as an IIS application. But generally, this is all of the clients are here. Now I will take the server folder. Okay, the server folder contains everything you need to run a server. I just take it. I copy it here, and I run the server. Now, this is one of the ways to run the server. As I said, it takes a few seconds to warm up, and then you get. No chance I'm reaching there. This is the bin number. Yeah. This is the time it took it to warm up. Now, this is the data folder. I unzip the server to here. The data folder is where the data will be persisted. It can be changed through configuration, but generally this is here. The server is listed on port 8080 on my local host. We will see how this helps us in a second. The storage is ECENT. ECENT is a Microsoft-powered storage engine, key value storage engine. It is capable of handling a couple of terabytes of information without any without crunking. And this is the API. This is the address of the server. Now let's see. I'll go to that address. Oh, sorry. I'll go to that address. I will get the Silverlight Studio. Now it is empty, as you can see, because I didn't do anything yet. I will use linkpad to show you something. What? Okay. Before linkpad, let's look at some code samples. No, let's use linkpad. Linkpad, I just saw this 2 days ago. I really like it. Generally, what happens here is they create. There is an extension to linkpad that lets you it lets you use RavenDB directly from linkpad, and you can just use it, compile a C# program, use it, and see the communication. So generally, what happens here? We check it to see if it works. Okay, what happens here, the driver creates a document store for me to that address up there, and it provides me a session. Okay, just like the code I can show you here, creating a new document store is done here. For example, you have you can see here there are several. This is the embedded document store. This is the embedded version. And after I create the document store, I can just work with the session. I create a session from the document store, I create a new object, I store it, I save the changes in, I commit them. Alright, and then here I can query. We will touch querying in a bit. But generally what happens here, I can do it from linkpad and just, I'm answering here. I will create an object through code, and I can show you how it is done through HTTP and show you it is committed to the studio. So generally what happens here, I created a new C# program, I selected the RavenDB as my server, and this is the code, right? Main function, I'm storing a new test object, I'm committing it, I'm saving changes. This is the actual class that will be saved. Now what happens is this, I run it, it tells me code is successful, I go to the SQL tab, and I see the HTTP communication. Now, this whole HTTP communication is produced by the client API itself. Okay? So we can see a 404 here, yes, on this URL. Docs, Raven, that means internal RavenDB document of hilo. It looks for an hilo because the client API needs to know how to give your new object an ID. Okay, so it gets a 404. That means no one has ever tried to save a new object of that type. Yes, and by the way, test object, this is my class name. Here I'm looking for hilo of test objects. Okay, there is a bit of play here on plurals to make sure we will discuss this in a minute while we are doing this. And the minute the client API gets a 404, it knows it needs to put a new hilo key. So it does a put, okay, an HTTP put, with the posted data you can see is max 1024. That means I want to have this range of values. This is not all that important. What important is this. I get back the hilo, I get back a confirmation, and then I do this. This is actually a post of the document itself. After I negotiated a hilo key, this is the. I actually get I get to post the document. The client API creates a unique key, okay, a unique identifier for this document. It has been serialized into JSON. All right. This JSON contains both the command and the document itself. The key is this. The method is put. All right. Because I'm doing a post, I need to tell the database what I'm trying to do against it. And this is the actual document. Okay, you see it is serialized into JSON. And it has metadata. So, now what the metadata means? We have an entity name and we have a CLR type. Let's go back to the studio. We will see those two documents within the studio. This is the RavenDB system doc. We won't touch that anymore. Now, this is the object that we created through linkpad, and let's view it. This is the actual document. This is its key. And this is the metadata. Now, we have an entity name, test objects, right? Plural. And this you can, okay, it's a bit tough to see now because we did this through link, but generally what this means is the class, the full class name and the assembly it came from, right? So this is the client API way to store your data from whatever code you created from to be able to deserialize it back when you query for it. Now, every document has a unique ID. That means I can create, let's show you. I can create a new document right from here. Right from this document. Just a second. Yeah, okay, I'm not used. Yeah, okay, unstable version. let's go back to a more stable version. Okay, this is the old studio, and this is data that we already have created. You can, by the way, this is multi-tenancy. Okay, we have several databases within one database instance with no actual cost. Let's use the default database, and let's create a new document. Now, the only things I need to do is type in a JSON and give it a key. The key is unique all throughout the database. Whatever key I give it, if I create another document under the same key, it will override the document on that key, that exists on that key. So let's create an Itamar document with whatever data. Once I save it, it is saved. I can see it here. This is the document. And I can edit it and etc. etc. Now, if I go and create a new document with exactly the same key, it will override. Okay? It is not creating a new document with the same key and version or whatever. It will override that. That means whenever I'm creating a new document with the same key, it will override the old document, whatever. Doesn't matter on my use case. This is why RavenDB uses the high-low mechanism to make sure that you have a collection. Okay, I'm defining a new term now, a collection, and which you can put new documents in. Now, a collection is not a table. It's not a table like in RDBMS. It is a logical unit that means that all of those documents have something in common. When you're using the client API, that something in common will be the class name from that assembly and whatever. If we go back, let's look at an object I know I created once. Yeah. No, that's not good. All right. This is the test database that we had for the new website. You can see here we have an entity name is what defines the collection name, and I have it for every document which is under that collection. It has that name. This is what created the collection through the client API. And RavenCLR type is this full class name with its assembly. That's what we call a full name of a class. And this key is actually assembled of both the collection name and a numerical ID. Now, this ID was created using the high-low mechanism. This key can be anything you want. It doesn't have any real importance. It is just very easy for us to understand to create them and to understand where they are belonging to. Now, I went a bit south here. Okay, this is Okay, let's use linkpad again. And let's create this object. Okay, created this object. We can see a post here, and this is what you get in the RavenDB console. You can see here what I showed you in the HTTP communication. The console app shows you right here. Here's the hello request, which is just a document in RavenDB, so you can just treat it as a document when we're speaking up. And there is the actual put here. RavenDB gives you, and this is the HTTP codes, 404, because we didn't find any replication document, which is something I'm not sure we discussed today. And you have 200, 201 to indicate that a hello was detected, a document was detected, and here is an operation to put a new test object. Is everything clear? Because I'm failing on, yeah? Now, after we've put this, we can now query. Querying, actually, let's do a load first. The API, I'm actually, okay. Now here, I can put either the string key that we saw before, which will be test objects /1 or / whatever it was, /3073, or we can actually type the int itself, which is much, much easier, and it will be converted for us. Down, this is a conventional linkpad. And we get this HTML, this HTTP code. We are going to docs/test objects/DAD. We get 200 to indicate it exists, and we get the result data, which is JSON. Now, we can access that through the browser. Just copy it. All right, you can see this is the JSON object we just stored. You can access it. The formatting is done through a Chrome extension. That's about it. And all right, this is the This is the way we query. We just access an endpoint on the server. Now this is the way we load. Now let's see a query. Just scroll. Okay. Now we are querying. Now the point here is we need to understand something. The way RavenDB works, we have the document storage, which is where all of the documents will be, and we have the indexing process, the indexes on RavenDB. Now these are two parts that assemble one server, but the server treats both of them a bit differently. You can access the document store in an async way. That means when the client API tells you the document has been put, it is there. You can load it immediately after. But queries work a bit differently. The way RavenDB works, to be able to let you search documents that you just put, it uses what's called MapReduce. How many of you here heard about MapReduce? Great. So that's actually a function you run against your data, and you map the data into fields in a Lucene index. This is how RavenDB does this. And when you query, you're actually querying a Lucene document, a Lucene index. So what happens here is this. We are querying the indexes of RavenDB through the dynamic indexes. I will explain in a second what's that. And we are querying a dynamic index of test objects. The query itself, it's a bit hard to see here. Let me just show you. The query itself is created through the Lucene query parser syntax. We has any experience whatsoever with Lucene. All right, Lucene actually is like, the syntax of Lucene is exactly like the syntax you're using in Google. You go to a search engine and you type the words you want to search. The search engine takes the words you want to search, does some processing with them, but generally it will search on a certain field. The field is the database content, the website content, right? So what happens here, when you do a map function, okay, when you do a map function, let's go back in a second. What RavenDB does when you query data from it, it will create an index for you if an index wasn't detected. It will try to find an index that was already created, but if it won't find an index, it will create one for you. The reason that is important is because we cannot search, unlike other databases, we cannot search without an index. It is not efficient, it doesn't make any sense, so we just create an index for it. But we return immediately for any query you create. So queries could be, let's go back to the slides. Queries could be stale. Yeah, I jumped a bit in the slides. Yeah. So queries in RavenDB must create an index to search on. Queries generally should be fast, fluent, powerful, easy to write, easy to read, and really good to handle in your business complexity. This is why we use Lucene, and we'll show you now. This is an unfinished slide. All right. So queries in RavenDB are defined using link syntax, which you probably know, and are strongly typed if you're using the client API, and are creating a Lucene index, which we will see in a second how it looks. Now, the actual index, once created, is run in a background thread to make it process the data through the map function and dumps it into the Lucene index as it goes. Now, the second you create an index, RavenDB already can return the results for you. But obviously, if you're creating an index for data that is like for a big collection of data, the query results won't be up to date. This is what we call stale data. This is a by design choice we made with RavenDB. That means we always return immediately. For queries, you might get stale results. The idea behind this is that nobody really needs non-stale results. Nobody needs up-to-date results for everything. When you do, you can specify that. But in general, you can get stale results. So once you create an index, we will run, process the data, dump it into a Lucene index, and then return from there. So this is why I said in the beginning, or I didn't, loads are async and queries are base. That means loads, whenever you don't query, whenever you ask RavenDB to load a document by ID, it will return immediately. Once you put a document, it is there for you to read again. Queries are base. Base means it is not necessarily there now when you're querying. I can't tell you if this document answers the query you submitted, but it might. If it is there, I will return it for you. If it is not, I will be able to tell you that I haven't processed it yet. I'll show you this in a second. But here we come to what I just showed you for linkpad. Okay. Other queries actually means you have put a lot of data in, probably, and you are only now querying RavenDB. Now RavenDB cannot give you any results without creating an index. So it will create an index for you, but it probably won't get the data, the most up-to-date data for your query. It will probably be, and it will be able to tell you if it didn't. Now, this is what, when this happens, when RavenDB creates an index for you, it will be an temporary index. It will be in-memory index until something about 25 megs, and it will reside there until one of two things happen. Either it has been promoted, that I will discuss this in a second, or you just queried it once, twice, and forgot about it, or you don't care enough about it, so it will be deleted. Now, if an index is being queried enough, it will be upgraded to a static index. Let me just close Skype. All right, so static indexes is what you create on your own. That means you can create an index. I'll show you the API in a sec. You can create an index by yourself, define an index from your code, from the client API. You can also create that on the studio, but it's not strongly typed, so it's a bit more difficult. And what happens with temporary indexes, which are queried enough is configurable. Temporary indexes that are queried enough will be promoted to static indexes and reside and be persisted. That means, unlike temporary indexes, which will be deleted once the server restarts or your server restarts, static indexes are persisted. Static indexes for this context are either indexes you created or indexes that have been promoted. Now, static indexes, why should you create a static index if you can just query and enough queries will promote? We recommend creating static indexes upfront because they both maximize efficiency and provide a lot of added functionality. For example, you can start create a full text search index, which is not the case in a normal index. You can create spatial index, you can spatial searches. You can create a lot of added spatial indexes that are supported by Lucene, but will not be created for you using the other queries. Another thing is MapReduce, which is if you're doing a MapReduce operation, not a simple map operation, you can only do that through the static indexes. Another point, which is important to note, we recommend creating static indexes because it lets you think more about the data you create, and we will get back in the slides to discuss a bit modeling to see how to really use RavenDB as good as possible. Creating an index upfront lets you think about your model, think about the use cases that you want to use RavenDB for, and therefore is good for your thinking process before starting to use RavenDB.
But if you have a lot of data in your database and you haven't made a special query, and then you make the query, does it return immediately also the first time?
Immediately. It returns immediately.
So it will not have any data the first time, or?
It probably won't,
okay.
But it will tell you that it is stale. Let's have a look. Okay, this is the query I issued a minute before from Untitled. You can see the results here. Now, if you recall, we didn't create any index there. So that means the index actually worked ad hoc on the data we put without just, it was created and returned immediately. However, it is fast enough to be non-stale. Okay? In RavenDB lets you know about the query that you made, if it is stale or not. If is stale is set to true, and it is all accessible for code. But if is stale is true, that means the query is not guaranteed to be up to date, the query results that you got. Now, through the client API, you can tell, don't return to me until the query is not stale. But we usually don't recommend doing that because in systems where you have a lot of data coming in, it can be indefinite, or at least a long time, which is not. But the point here is, although the query was created on the same second I made the query, it did return a non-stale. That means the indexing process is fast enough to work. work nicely. Now, okay, okay, so here are the results, and you can see I'm querying RavenDB through the REST API, through the HTTP API. Here is indexes, dynamic test objects. Test objects, as I said, is the collection name of all the documents I'm looking for. And this is the Lucene query syntax, which we will not get into now, just show you through the studio one example. And here are the results. Here are the objects, 3 objects, because I created them 3 times. And I don't think here now, but probably before. 3 different objects, I get their IDs. You can see that through the IDs, 1, 10, 25, etc., etc. 4 objects, 5 objects actually. And here's the metadata RavenDB saves for each object. It's internal metadata, internal data that it remembers for each document what is the entity type that is the collection, the CLR type, how to deserialize it. This is not important now. Last modified, an E-type to tell you what version of the DB it was created on, and etc., etc. Now, here are the indexes that are created on currently on the. I think it's not happening. Just a second. I can't see. Okay, probably caching issue. I wanted to show you how to query. Right. Here's the temp index that was created while I was querying. From doc in docs.test objects, select new the property to select. Now, this is the link query, link expression, simple link expression. What it does, it maps this property from the object, from an object, into this field, this Lucene field. All right. Now, reduce is another operation which is built on top of that. I won't show it now, but generally what this means is if I have an object with a lot of properties, through this link expression, I select which fields to index. All right. I can even tell RavenDB how to index them. There are different options. Perhaps we'll get to that today. But generally, this property will be indexed. So that means I can search on this property. Now, if you look at the query I made, this is actually what I did. I queried a test object where test prop is different from AS because I wanted to get all the results and I knew I didn't have any property with this value. Now, the RavenDB knows to take this query, which was translated into HTTP code, and create an index that will satisfy this query. Now, through the studio, I can query. First, these are all the objects that satisfy an empty query for this index. Now, I want to actually query this index. So I know I have a test prop, and I know this query returns results. So let's use that. Actually, this is okay. Let's do it differently. I know this value exists, right? So let's query based on this value. Now I know I have this property, and I map to it. So test prop. This is like you using Google, for example. You're looking for keywords, and you can, for example, limit Google to search only on a certain site. So you type site colon, the site name, space, and the keyword. This is exactly the same syntax here. Site, think of site as a field in the Google index. This is what happens. Here I found the document with this property. I can change it a bit and I won't get any results back. So basically this is if I had more properties, I could type the property name, property value, etc.
But if you didn't already have an index on the other one, then you would not get a result the first time you query.
Yes, we will. What will happen is it depends on the way you executed your search initially. The worst case, we will create a new index for that. Yeah. This is the work behind the scenes that the query optimizer, RavenDB query optimizer, does things. Perhaps it could even be improved to support such things. Like index everything on the first time, all properties, to just make sure this stuff doesn't happen. But again, it should only be the case for development. When you create a new application, use that. But when you go to production, make sure all of your queries are using static indexes that you created or promoted temporary ones. That's the recommendation. I have some syntax things. Yeah, let's go over the bit of syntax. You can see a queries here. Okay, let's go ahead one and then go back. Link is just a syntactic sugar. That means whatever link expression you write will be translated to methods like we just saw. Okay, so we have session query for an object company, and this is the actual expression we're looking for. We're looking for a company name of hibernating rhinos, or we are looking for number of happy customers is more than 100, etc., etc. It is equivalent of this link expression from company in the query results, where company name equals that, select company. Those link expressions and those commands or expressions are equally the same. But okay, let's notice how we will play with it. You can just query everything in a fluent language. It just works. Okay, paging. We'll get back to paging in a second. Let's discuss modeling. Is there anything on the basics what I just saw until now that is not clear, that anyone has a question?
If the structure of the class, the definition of the class changes between a store and a get,
right.
what?
Let's discuss modeling and then we'll go back.
Okay.
The general answer is the DB is schemaless. You don't need to do anything. It depends on how the class changes. Because
so it's up to the client to handle, or?
Again, it depends what happened. You drop the property, you edit the property, you change the property name. That really depends on what happened. I'll answer that in a second because it requires a bit of more knowledge.
Can I promote an index from the studio?
No. We have a ticket for that. We promote from the client API, but it's possible. It's a matter of function call. Okay, modeling. Now, the main problem I'm stopping for now, pausing on the API and all of the stuff to take some minutes to talk about modeling, then we'll go back to APIs. And also, if anyone has a question on API, this is the time to ask, or after the modeling part. Any other question? The main problem with any document like this is to model it correctly. The idea is that unlike a relational database, we are now working differently. We are now thinking differently. We don't need to split entities apart. We need to somehow work in a way that makes sense to document databases. Domain-driven design, who has ever heard, used, who doesn't know what domain-driven design is? Great. Domain-driven design, so I don't need to introduce that. It's a way for us to talk about our domain, our business domain, in terms of in our applications, in terms that do not require much of differentiation between reality and code. Unlike relational databases, where we had to start splitting things to make it work with the databases, domain-driven design allows us mostly to work with the real-world data as we see it. Now, okay, so domain, you know what is an aggregate root. Who knows what aggregate root is? Great. So again, we are identifying something that is internal in our domain, and it is transactional unit, however you want to look at it, and we're just saying, okay, this is my main object, and this is what I'm going to throw into the database. Okay, in terms of document databases, we will discuss aggregate roots. We'll try to identify them, use the domain-driven design tools to do that, and throw them inside our database. So in practice, how will we work with RavenDB? We will start to model our domain model, and we'll create simple .NET classes, POCOs, to do that. In domain-driven design, we usually use denormalization to bypass some problems in the way, so it is loud, unlike RDBMSs where denormalization is the cardinal sin. You have to normalize. Denormalization here is good. Each entity can have references to other entities. Although we are using aggregate roots and everything else to allow for performance, RavenDB allows relations. We will talk about those. And of course, identifying aggregate roots, which should be up. Okay, now when you design your model, think about the use cases. Think about how users are going to interact with your application, with your data. What are the frequent usages scenarios? What are the operations that are not so common? Like sometimes you have different considerations to do for each side. So you probably want to choose the model that makes most sense for the most usages, for the operations that your users are more likely to perform. What I'm talking about, there is always a dilemma, optimize for reads or optimize for writes. Most applications will want to optimize for reads, because writes are not so often. Think about blog, for example. How many posts are you posting a day? On the other hand, how many people read your posts? So if you write one post per day, and you have 100, 200 reads per day of that post or other posts as well, you probably want to optimize for reads. How does this come into practice? Let's think about orders. I have an e-store. I want to save an order. What will be my aggregate root? Okay, guys.
The order.
The order will be an aggregate root. Now, where will I put all the lines?
Inside the order.
Inside the order. Now, can you answer why?
Because it wouldn't make sense to get an order line without the accompanying order.
Correct. No, right. Now, order line has no meaning at all without the context of an order, right? So, in RDBMSs we had to do that because we didn't have where to put all the lines in a way that made sense. Now, here we don't have any reason not to do that. So we create an object which is in order. We create a list of order line items, and we just store this whole object graph inside RavenDB. It will be serialized into a JSON object with an order, all the details of the order, and an array of order lines with all the data inside. Now, the same goes to blog posts and comments, I would think. Why? Because blog post is an aggregate, definitely, and comments have no context at all outside the context of a blog post, right? Can anyone think differently?
What if you have 10,000 comments?
What if you have 10,000 order lines?
Yeah. Would you store them on the aggregate root?
Right. So this is a good question. There are more factors to take into account. Generally, this is correct. This is a correct way of thinking. But, as I said, you should think about optimizing it for reads, for writes, or use cases, usage scenarios. So what happens is this. Anyone knows Raccoon Blog? Everyone saw that? Okay, Raccoon Blog is an official sample application of RavenDB. We created it to demonstrate how to work with RavenDB. We are now refactoring it a bit, but generally This is the structure of a blog post within RavenDB. It's not all the properties, but generally you have ID, title, everything, all this information. You have author ID, which is a reference to another object, and you have these two fields. You have comments count and comments ID. Now, what happens here is we don't store the comments within the blog post aggregate root. We are putting them in a different object, which looks like this. We have the post comments. It's a class. It has an ID. It has a post reference with some data in it. We have two lists of comments and spam comments. And this is a field we use to generate IDs, new IDs. Now, what happens is this becomes sort of an aggregate root for comments, not exactly, but generally. Now, what happens here is we create new comment, we store it within this object, and we store this object back. Now, why would we want to do that? Any idea?
If you want to read a blog post without the comments.
Correct. What happens is, Raccoon blog, by the way, is used in Allende's blog, in our company's blog, maybe in other blogs we don't know about yet. But generally, it is being used very, very, very extensively already. Now, what happens when you go to a blog and you read the category, you read the main page? We don't want to load the whole blog post aggregate with all the comments, which could be in tens of thousands. Yeah, probably not. Yeah. Even loading 10 comments when you don't really need them is a waste. A waste of bandwidth, waste of a lot of things. So we don't do that because we know the usual scenario is where you read a blog post through, I don't know, through a reader, through the main page. Most readers will not really read the comments. So what we do is we store the comments in a separate object, which we can load if we want to, and the comments count is stored within the blog post object. So when you load the object, you can know how many comments there are, and if you want to read the comments, you go into the blog post context and then load all the comments and this object for display. Now, the RavenDB website, the new website. How many of you didn't see the new website? Okay. Okay. The new website works a bit differently, and different considerations. The new website does something like that. We are not. Okay, it's not a blog post. I don't know why I wrote blog post. It's not a blog post, but generally we have a content entity, which could be either documentation, which could be a knowledge base item. Could be a news item. It's a content entity. The content entity will not contain the comments within it for the same reasons, but it will also won't have a comments object. It works a bit differently. What we do is we create. Let me show you. Unless it's not open. But whatever. We have a user comment object, which we create and store as is. It will be given an ID, it will be stored just as a normal entity, and it has an ID of the content item it refers to. Why do we want to do that? Because it allows us to better paging. Unlike in the Raccoon blog, we took a decision not to do paging, which we need to discuss a bit in a second. But we just load all the comments and show them to you because we're not expecting to have too many comments per blog post. But unlike Raccoon blog, in our website we do expect to have a bit more comments sometimes. So we want to provide paging. We want to allow you to read through the first 10, 20 comments, and only if you decide to read more than that, we will be loading more. Now, this is impossible or doesn't make really sense to do using the Raccoon blog approach. Since the Raccoon blog approach, you will load from the DB all of the comments, and then whatever you show, okay, but you already loaded all of the comments. Using this approach, we can only load a page of comments for that content, for the content ID, and load more if we want to. This is the paging slide, which we will get back in a second. Now, this also allows us to enable replies to comments. It is also possible to do through using the KANMalmo approach. It's a bit more difficult. This way, each comment can have replies to it. So when you load the comment, you'll be loading the comment with all the replies to it. We wanted to have replies to comments, again, unlike KANMalmo. And it's easier on transactions. We actually had a bug on KANMalmo for quite some time when two people would be commenting on the same blog post at the same time, only one will win. We realized that, we fixed that, but generally when you're writing a single object within using RavenDB, using the client API, you will be actually doing a HTTP put on the key, on the given key of the document. Now what happens if two people do the same put command on the key? It will be, as I said, it will be the last one wins. And then you will have one comment lost. So RavenDB has a way to maintain this, to resolve this. You generally want to check that the version you have, it's basic eventual consistency. You generally want to check the version you have answers to the latest version when you are posting. And you ask RavenDB to tell you if it's not. But using this way, posting a new comment doesn't require as much work. It will only be required if you're doing a reply, since the reply actually works like in KANMalmo. But otherwise, it is much easier. It's much faster to work with. Okay, this is queries again. And okay, let's talk a bit about safe by default. Now, one of the design decisions for RavenDB was one of the design decisions in RavenDB was to protect you from yourself as much as possible. That means one of the problems with an hibernate, with ORMs, and whatever communication you have outside of your application, even to web services, is over-querying. That means getting more stuff that you actually need. How many times did you do a select star from table? This is bad practice generally, and on big tables, this could crash your application, eat your bandwidth, etc., etc. So what RavenDB does, it defines the notion of safe by default. First, it will not allow you to query more than you actually need. It will not send you, won't give you, by default it will give you only 128 results per query. You can enlarge this up to 1024 results per query, and then you have to configure the server to allow you more than that. That means if you want to shoot yourself in the leg, you can, but by default we won't allow you to hurt yourself. We only give you as much data as we think you need. Other things are like, we won't allow you to make more than 30 requests per session. That means you can do a certain amount of stores and loads and queries until you reach the quota. And then if you reach the quota of 30 queries per session, you're probably doing something wrong, because you shouldn't be doing that much of operations. Now, I mentioned we also provide facilities to allow you to make things that you actually need to do them efficiently. 1 second. Right, I mentioned we had an author ID. Now, when I load a post, I want to get the author as well. Now, the reason author is not within this aggregate rule is because it has sense outside the scope of a blog post. And one author can have several blog posts, and I want to be able to change it only once. Now, okay, it actually answers his question. When I can put any entity I want within its collection and store the ID of that entity within any object I want. RavenDB has the notion of includes. It lets you to define which field is an include, and that field, the value of that field, will be used to load that entity for you. If you see, this is the query we made before. This is the results. We call it the results pipeline. When you do a query, you get the results in the results pipeline. There is also the includes pipeline. When you query, it is also specified by the HTTP command we send to RavenDB. You can tell it which fields to include. Now, if I had, let's assume this test prop, the value of this test prop is actually an ID of another entity somewhere in the database. Now, as I said, IDs are database wide. That means whenever if you have an entity with a key of AAA, that will be the only entity in that database with that key. So you can, if you specify test prop to be an include, you tell RavenDB to include that. When you query, you will get all of those objects like you're seeing it now. And in the includes pipeline, which is again transparent through the client API, you will get all the objects that has keys with that are mentioned in the test prop. You will get, okay, everything is AAA, but you will get the object with key AAA. You will get with this, etc., etc. I'm not sure I have a slide here that shows that. Yeah. Here's an example. Okay, the usual select n plus 1 is when you are querying for orders, for example. This is not exactly what I want, but anyway, you are querying for, actually I have this in the docs.
But what is that you include? You include the other object, the other aggregate group, or just the ID?
Let me show you. No, the whole object. Let me show you. Yeah. Now, this is a classic select n plus 1 on any database that you can think of. If you ignore this line, this will be a select n plus 1. You query for all orders that satisfies a condition, yes. All orders that has their price is more than 100 SEKs, and you perform the query. You have no other way, and then for each order, you want to load the customer of that order. Now, the customer is again customer ID because it has sense outside the scope of an order. Now, when you do this, you get select n plus 1. With RavenDB, you will get an exception thrown if you have more than 30 orders. Why? Because you make one query here, and then after 29 loads here, you will get an exception that you use too many sessions, too many operations in one session. This is how RavenDB is safe by default. This is how RavenDB protects you from yourself not to do a select n plus 1. Now, this is where includes come in. Okay? When you query and you know that you can get a select n plus 1, you actually do this. You tell RavenDB to include, using the order object, this property, and it will, for every object it will load during the process, it will take this field, load the entity with that key, and throw it in the includes pipeline. Now, when you do this, when you perform the load, nothing will happen because it will just go to the document store cache. It will load the JSON serialized customer, deserialize it into your session, and you will get customer change tracked as a unit of work here. without any further query to the database.
Okay, so it does it just the first time, all the queries, including the customers in this case.
I'm not sure what is the first time.
No, but I just try to understand. Instead of you having, it does already the querying on the customer in the first part of the query. So in the for each you already have it, both the customer and the owner.
Not exactly.
Okay.
Here, I had a list of orders.
Yeah.
Yes, deserialized.
Mm-hmm.
But the document store, I'm working against the session here.
Yeah.
Okay. So the session, when I queried, I got to the document store the two pipelines, the results pipeline and the includes pipeline. Right. The results pipeline was deserialized into a list of orders into this variable. When I'm here, I only have orders deserialized and change chart, right? Unit of work of orders. Now, when I'm doing for each here, I'm going through every order in that array, in that list, okay? And when I'm doing the load here, every customer ID that I'm loading is being deserialized to this session from the document store cache.
Yeah. Okay.
Until here, okay, each customer was saved, was cached in the document store as JSON. It wasn't deserialized yet. Okay? We actually have two levels of caching here. And here we get to caching. First, you have caching on the document store level. Whenever you make a query, whenever you do a load, we save the entity we got from the server, we save it with its key in the document store, which, as I said, is a singleton. It's static. It exists once, and it should exist once for every application. And whenever you do whenever you do an operation with the session, we deserialize that object from JSON to an object. We register it for change tracking as unit of work, and let you work with it. Now, what happens here is exactly that. We here the two levels are applied to the orders, but only one level is applied to customer. The customer is saved on the document store level. When you do load, it will deserialize and be saved to the session. And of course, when you dispose of the session, all of the objects deserialized will go away. Okay, this is a bit about CVD. Any questions so far? Okay, smart people. Let's see what's in the agenda. So we talked about how to run a server. We talked about a bit about the API, and we just talked about a bit about modeling. There's a lot more to do on modeling. So we can resume on extending. Maybe I have something more here. Okay, again, this is paging. We need to cover paging. As I said, RavenDB is saved by default, so it won't let you page take large pages. But generally, this is the API for paging. Very simple. I think next we'll build a small application just to demonstrate all of them. But this is the way you will page. You will skip an amount, you will take an amount, and that's about it. You, of course, this is a query with no where clause, but of course you can add a where clause and everything. Once you take more than a certain number, RavenDB will shout at you. Okay, this is what we just talked. Now, whenever you have an entity, whether you got it from load or from query, you can make any changes that you want to. But it won't be persistent unless you call save changes. Many people come to us and ask, they don't understand why it didn't persist. So unless you call save changes, nothing will persist. You can change properties and everything, but unless you call save changes, it won't be persistent. Now this is the API to actually know whether your indexes are stale or not. Okay, you are doing a query. We are a bit changing a bit the API now. There's some guy makes changes to this now, but generally this is the API for that. You create a statistics object, you pass it during the query, and after that you have the total results. That means you got back a certain amount of results, but you want to know how many results are they in the whole database. So this will tell you that. Skipped results is sometimes you get duplicate results because in the results count because of distinct values and distinct operations and stuff like that. So it is available for you as well, and a correctly made done paging is done like this. You skip the current page times page size plus skip results, so you can skip the irrelevant results. And stale results again is available from the query statistics. Okay, this is once you have the query statistics object, you can ask it is stale, and it can also tell you what index it used, what is the timestamp, and everything. Now, when you're querying, you can tell RavenDB from the client API explicitly to wait for a certain amount of time or for a certain period of time. No, I mean, to tell RavenDB to give you results relevant to that at a certain point of time. This is done using this API. Wait for non-stale results as of now, as of a date stamp, or as of last write. If you just made a write to RavenDB, you can tell it to wait just for that write and not for a specific date of time. Again, in the general case, it is not recommended. Only use that for testing or in specific scenarios where it applies. And we have live projections. Let's do a simple application. Anyone has an idea of application wants to see? Guys? Okay. Let's create a simple block. How are we done? Good?
I don't have
Next session. I'd really like to see you model a tree structure.
A tree structure?
Yes.
Tree of what?
Tree of nodes, whatever. Where each node has its boundary. How do you make a performance query ready to load?
Okay, let's discuss this. What do you want to load? That means tree, generally, I will probably model using parent, just the parent, and either its children references to its children or reference to its parent. I will use each parent as an aggregate, but an aggregate in its own object, because I will want to bypass the limitation that you probably indicated, that it can be really, really tiresome.
Yes.
But for some cases, I will want to have a big document for that. For example, we have generally in blogs you can find tags, but sometimes you will find categories. Now, categories are structured by definition, right? But the structure of categories is made of one. That means when you have category, you want to move it from this branch to another, you're practically changing the whole category tree. So you have scenarios when you will want, we had this in Melodies lately actually. You will want to use to save each parent or each branch or whatever as its own object. But for some cases, you will want to have one large document containing everything. So this really depends on what you're expecting from this object, from this category tree.
But I'm thinking like a normal website. where you have a menu, where one page can have subpages, and those pages can have their subpages, and so on. And you want to render the complete menu. That's a
You want to
classic.
build a menu or the pages hierarchy?
Perhaps the page hierarchy.
Okay.
So how
Let's
would you
try.
without doing an n plus 1 plus 1 plus 1?
Okay, we have a function in the transform results. Okay, let's talk a bit about transform results. The indexes in RavenDB are built using MapReduce, okay, which lets you, the map function lets you take the objects and map them to index fields, which you basically search on. Reduce function adds another level if you want it. That doesn't, when you have a reduce function, it will generally, instead of putting the mapped results in the index, it will do further processing and put the reduce results into the index. It is basically the same, it just lets you group by stuff. Perhaps we'll see that in a second. And you have another level which lets you transform the results, whether you use map or reduce or you didn't. After the results are getting back from the index, they are getting back, of course, you have access to the properties of the objects and everything, but after you're getting them back, you can iterate through them and do further processing. Now, the MapReduce functions are made once on indexing. Like after you're putting in the index or you're making changes to documents, the MapReduce functions will run. The results will be put to an index, and then you search on that index. The transform results function, what we call live projections, will run on every query you make. Right? They let you change the results a bit before you send them back to the user. Now we have a function which does something like that, which is called recurse. That means it can let you go deep and deep and deep and create an hierarchy. Okay, based on it's very specific. It's very specific use case. I can show you later. It's a bit difficult to show now. But generally, the recurse function can answer that. But the question is whether you do need a tree or not. Because if you have pages and the pages themselves have parents, just say each page can be big and you can load each page individually, right? So you don't want the page itself in a tree. Now, for a menu, you can either save the tree as is, with IDs, and do an include on those IDs. You can use transform results to do that. You can use the recurse function, etc., etc. It really depends on the use case and everything. I think it's too much details to go into now. But generally, you have several options, and you really need to weigh your use case. Okay. I'm really out of ideas on website or application separation. Anything specific you want to see?
Maybe it's a good time to break out and people can come to you.
Yeah, sure. Sure.
Yeah.